Hey, what's going on, guys? Let's try this problem right here. Here we have an object that is moving with 0.5 c velocity, and the question is asking what's going to be the kinetic energy of this object, right? Now let's see how we can figure it out. And you may remember the old equation, that is, we use this one mostly, right? That is Ke is equal to half mv square. And if you apply this one in this equation, let's see what we get. From this one, we know that half times mass is 1 kilogram times velocity is 0.5 c. So this is going to be 0.5 square times 3 times 10 to the power of 8 meter per second square, right? And if you calculate this value, you will get 1.125 times 10 to the power of 16 joule. And this is not going to be the correct answer. You will see later. So this is not going to be the correct answer, right? Because this one doesn't work when we have an object moving with this velocity. Now you may think, okay, if we move this one with very high speed, the mass is going to increase. Maybe let's try plugging, instead of mass, let's try plugging gamma m naught instead of m and see what we get, right? So if you try that one, let's see what you get. Like, kinetic energy is going to be half times, instead of m you plug gamma m naught times v square, right? So here we have to calculate gamma first. Gamma is basically this one, 1 over 1 minus v square over c square square root. And if you plug the values, this is going to be 1 over 1 minus 0.5 c square over c square, right? This c square cancels, and you will end up with this equation. And if you calculate this value, you will get 1.1547. and if you plug this one in this equation, this is going to give you half times, and we have 1 kilogram right here, right? So this is going to be 1.1547 times 1 kilogram times v square is going to be, we know that 0.5 c, so this is going to be 0.5 square times 3 times 10 to the power of 8 meter per second square. And if you calculate this one, you will get 1.299 times 10 to the power of 16 joule. And this is also not going to be the correct answer. So what's going to be the correct answer? You will so to find that one, we use this equation. So when you have object with very high speed, like near to speed of light or more than 10% of speed of light, you always have to use this equation to calculate kinetic energy. Otherwise it will be wrong. No matter how you change this equation, this old equation is not going to give the correct answer. Now let's see if we use relativistic. So this is called non-relativistic kinetic energy equation, and relativistic kinetic energy equation is going to be this, that is E total energy and minus rest energy. So this is the relativistic equation. We always has to use this one when we have a speed that is 10% of speed of light or more than that. So it's going to be like even 10% of speed of light is going to be very high speed, right? So when we have very high speed, we have to always use relativistic kinetic energy equation. Here total energy is this equation, mc square, and rest energy is m naught c square. Here m naught is rest mass and m is relativistic mass. And this rest energy basically means if you take a mass and completely convert this one into energy, that's going to be the rest energy, right? Now let's go ahead and plug these values, plug this equation and see what we get. So first of all, we have ET, that's mc square, minus E naught rest mass, that's going to be m naught c square, and here we can take c square common, so this is going to be m minus m naught times c square, right? And we know that m is equivalent to gamma m naught, so we can replace this m with gamma m naught minus m naught c square. And also we can take the m naught common right now. So this is going to be gamma minus 1 times m naught c square, and we have calculated the gamma already, right? So we can plug this one right here. So this is going to be 1.1547 minus 1 times m naught rest mass, that is 1 kilogram, times c square, that's going to be 3 actually 0 point, no 0 point. So c square is going to be this one, that is c square. C square is 3 times 10 to the power of 8 square, and if you calculate this one you will get this value, that is 1.392 times 10 to the power of 16 joule. So this is going to be the correct answer. So the kinetic energy is equal to this value. So therefore, and whenever you have the velocity more than or equal to 10% of light, you always have to use this equation. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.